In this lesson, we'll focus on controlling the lead or lag of the tool. After completing this lesson, you'll be able to modify a multi-axis contour to change the tool forward tilt, modify a multi-axis contour to change the tool sideways tilt, and identify multi-axis contour tool parameters and what they change. Let's carry on with the file from our previous example, and let's talk a little bit about controlling the lead and lag of our tool. We're going to go back into our multi-axis contour toolpath and edit, and we're going to navigate to our passes section. Inside of our passes section, there are many different things in here that we can modify and manipulate. The first of which is our cutting mode. And the cutting mode will specify how it's going to machine along the contact curve. For example, we have trim impossible, we have fail when impossible, and turn when impossible. So we're going to leave the trim when impossible option turned on, but again, we do have some parameters that we can adjust here. Also note that our sideways compensation allows us to keep the center on the contour, or we can offset to the left or the right. If we offset to the left or the right, then using an axial offset amount can move where the contour is in relation to our selection. Let's go ahead and zoom in a little bit so we can see our contour a little better and focus on some of our parameters. So right now we have a handful of parameters, and again, in Fusion 360, whenever you hover the cursor over one of these dialog boxes, you'll have a tooltip that helps you understand what this amount is. Now in some cases, like axial offset, you don't get a graphic preview of what this adjustment is going to do to your toolpath, but we still have a tip that tells us it can be used to shift the selected curve up or down in the spindle. We also have pass overlap, which will allow us to extend the distance at the start and end of the curve, but then we really want to focus on forward tilt and sideways tilt. The first thing that I'm going to do is I'm going to adjust the forward tilt by 15 degrees. I'm going to say OK. Allow this toolpath to recalculate, and then we're going to go into simulate. However, you'll notice even though our toolpath is displayed on the screen, we have a warning. The warning is telling us that the lead radius has been decreased to avoid linking gouge. So we still have a toolpath there, so let's go ahead and simulate it and see what the tool is doing. Remember that we can play the simulation, but we can also hold down the left mouse button and simply drag through it. If we view this from the top, you'll notice that the tool is shifted forward in the direction of travel slightly. So as it's moving around, it has a slight lead angle on the direction of travel. If we modify this toolpath, go back into our passes, and we try to enter a negative 15 degree value, once the toolpath has been calculated and the preview on the screen is displayed, you can see now the tool is angled in the other direction. If we simulate this, again, simply dragging the cursor in the bottom section, you can see now that it's pushing the tool rather than dragging it. This does adjust as it goes around the contour that we've selected, so you can see this is a great way for us to control how the tool is interacting with this edge. Let's go back in and edit the toolpath again. We're going to change the forward tilt back to 0 degrees, and now we're going to adjust the sideways tilt. Now at this point, it's tilting about 45 degrees as we're looking at it about the x-axis. So if I change this to 25 degrees and say OK, and we take a look at the toolpath, let's go ahead and simulate it and go ahead and drag this around and see what the tool is doing. So that positive value has changed it so the tool tilts down farther against the contour. You'll notice that in this case our holder is actually colliding with the part. However, it is still allowing us to move around and take a look at the toolpath. So if we go back to our toolpath one more time and edit, go to our passes, and we change this to minus 25 degrees, allow it to again recalculate. Let's go ahead and simulate this. And now instead of the tool being angled down further, it's angled closer to the original z-axis. So again, we can drag around and take a look at how this toolpath is moving, but these values allow us to control the tool's interaction with this edge. So once again, in the passes section, we have our forward tilt, which positive and negative change whether or not the tool was leaning into the contour direction or leaning away from it and pushing into it. And then the sideways tilt allowed us to have a positive value, which allowed us to lean farther down, and a negative value, which allowed us to stand up a little bit more. I'm going to change these both back to 0. I'm going to change my sideways compensation to left, and then I'm going to add an axial offset value of -0.05, say OK, and allow this to calculate. So what I want to do now is I want to focus again on what some of these values are doing. So if we zoom in and we take a look at this, and if we simulate it, we can see now that the tool is actually below the edge. So it's shifted down, and while it still is contacting that edge, it's contacting it with a different part of the tool. If we increase this value, then that toolpath might move a little bit too far away for that edge to contact it, and the tool angle might have to change. Notice that in this case we actually do get a warning telling us that the lead radius has been decreased to avoid that linking gouge. Back in Edit, let's go ahead and go back to our passes, change it back to center, and reduce that axial offset back to 0. Now I'm going to increase my pass overlap, and I'm going to do this a distance of 0.5 and say OK, and again allow this to recalculate. We can see this on the screen exactly where the tool is starting and ending, but if we simulate this, we can see that the tool is starting on the lower left-hand radius, it's moving around the part, and it finishes on the lower right-hand radius. So this value allows us to go past our start point to make sure that we're not creating a small imperfection in that corner. So again, this was our pass overlap, and we can set that back to 0. So there are many other options in here that we can talk about, but these are just a few, and sometimes exploring these options with a simple 2D curve can help us understand what they're changing. A lot of times, if our contour selection is actually a true 3-axis contour, well then it can start to be a little bit more complicated understanding what some of these parameters are doing. We're going to explore this a bit more, but for right now, let's navigate back to a home position and save our file before we move on to the next step.
Thank you for watching our channel. Please like, share and subscribe our channel, and don't forget to press on bell icon.